Yeah, good afternoon. Um, this is the third session at the intermediary class. Webster Applied Data Analysis Masterclass for research and undergraduate final year project. I still remain my name, Abdulaziz Abdulaziz. This is how and what today's class will look like. We are going to be talking about how to identify or how to decide which statistical tests to use during data analysis. However, we will achieve that by first of all identifying the independent and dependent variable. After that, we can do that by also identifying the nature of the variable. We will also um, decide on which test to use after we have carried out our normality test, which we've done in our previous class. So for information on how to carry out normality tests using SPSS, check previous videos. Now, what is what is a dependent and independent variable? As I've said briefly in our earlier session, dependent variable are those variables that don't change. However, independent are variable that changes. An example will give you an insight of what this really means. So then I will share a spreadsheet that I prepared just to explain this. Now we have two groups. The first group are those who love Coke, like me, and the second group, those who love Fanta. So I will code them as group A and B. Now for the first group, we have 5 participants in both groups, 1, 2, 3, 4, 5, and we have another 5 participants. This is the serial number. I can indicate it. Serial number. Excuse me, serial number, yes. So we have the first participant, second, third, fourth, then fifth. For 2 groups, we have grouped them into those that love Coke and those that love Fanta. Now this is their glucose level. After we intend checking for their glucose level, that's the level of their glucose, blood glucose in milligram per dl. We notice that after consuming Coke, we now want to check their glucose level. Likewise for Fanta. So we have 2 groups now. Now these 2 groups are the independent variable. They are the independent variable. Unlike these variables, the other variable that changes with the number of with the participants. Participant 5 for Coke is different from participant 5 for Fanta. Participant 4 for Coke is different from participant 6 for Fanta, and so on. So this variable changes, and this is the dependent variable. Glucose level is the dependent variable. So glucose level in milligram per dl is the dependent variable. And the glucose level are the 4783673 milligram per dl. So they are the dependent variable. However, our groups are the independent variable. So a dependent variable like this glucose level can be continuous, as we've seen here. Continuous variable are those variables that have decimal. They are the measurable variable. Glucose level is measurable. So they can be continuous. They can also be categorical, as in the case of this. Now, this is the same thing, but the only difference is that instead of glucose level, I'm replacing them with a categorical variable that is male and female. Male and female. So those who are male in group A and those who are female in group A, likewise that of group B. Now, this shows that our um, dependent variable can also be categorical. And don't forget, you wish to know that even our independent variable can also be continuous. So let's go back to our slide. Having explained that, we'll go back to our slide. Now, I've talked about how we can identify dependent variable and independent variable. The dependent variable are those parameters we are running in our research, or the factors we are measuring most of the time, now our independent variable in most cases usually used to be um, the our independent variable usually used to be the parameter we are running, or the factors we are assaying, the factors we are determining, such as maybe if you want to check for um, um, blood glucose level, if you want to check for the full blood count so those full blood count, blood glucose level, they will change. We change in individual, but the group they are will not change because we grouped them. So those that are changing, the parameter we are measuring, are the dependent variable, while those groups are the independent variable. In most cases, you are going to encounter such. And we'll identify the nature of the variable, whether it is continuous or categorical. You need to identify that. You need to identify that. And also, like I've said in our previous class, you need to check for the normality of the variable. So the normality of the variable will determine which statistical test to use. If the normality is not is not normal, or the variable is not normally distributed, then you have to change from parametric to non-parametric. Now, what are the parametric tests? Parametric tests are the t-test, ANOVA, Pearson correlation, yeah, etc. I repeat, parametric tests are the t-test, ANOVA, and Pearson's correlation. Now, after you've identified um, uh, all those important key in deciding the statistical test to use, the next thing is to know which statistical test to use. Like this table is indicating, if you have a dependent variable that is categorical and you have an independent variable that is also categorical, then the test to use is chi-square. If you have the dependent variable that is continuous, like I've seen, like here, and also a categorical variable of independent variable, then you should go for ANOVA and t-test. Likewise, if you have a continuous, dependent and independent variable, we go for Pearson's correlation and categorical dependent variable with an independent variable of continuous nature, then we go for the logistic regression. We can always come back to this table to know which statistical test you are to use. Now, what is a comparative research data analysis? This involves data analysis that are used by a random sample of data taken from a population to describe and make inference about the whole population. In other words, it simply means um, picking data from a population and comparing it with a control. just to make inference. So if you pick data from a control, like I'll still go back to the glucose level we are talking about. If you pick data from a certain population, and you are comparing the glucose level of that population to a known control. Now, a known control can be a known control, or it can be another group of population that are the control, whichever way. And we're going to be explaining how to treat them um, in, as the class proceeds. Comparative research data analysis is valuable when it is not possible to examine each member of an entire population. Definitely, you cannot really pick everybody in a population and now start assaying. If, for example, you want to run the glucose level that we're talking about in, in Lagos Metropolis, you cannot collect sample from everybody in Lagos Metropolis. So all you need to do is just to pick some fraction of the whole of glucose of the whole of Lagos Metropolis and use it as representative, thereby comparing with a known control. The known control can be a known control population, or it can also be a, a, a known value to be the control. And after doing that, you will be able to make inference. Inference simply means you make conclusion, or you get a result that the population, the sample from the population, the glucose level from the population is different, or it is not different with that of the known control. So you are comparing. So by mere looking at a set of data, you cannot give a conclusion that the of two groups of data are different. Let me explain. For example, I'm going back to my spreadsheet on Excel. Group A and Group B, you cannot categorically say just mere looking at it, even though you want to calculate the mean, you cannot by mere looking at it and conclude that Group A is different from Group B statistically. For example, if I am to find the mean of all the value for those who consume Coke, that's the A group, the average is 4.6 for A group. For Group B, yeah, for the other group, the average will be 6.4. Now, mere look, by mere looking at it, you will notice that Group A have lower value than that of Group B. However, it is not enough for us to totally conclude that there is a difference statistically in the two groups, unless we run the statistics. Just by mere looking at it, you can't conclude that Group A is lower than Group B statistically. So we need to look at it. So we need to look at it in a statistical point of view. Now going back to our slide, going back to our slide, we are going to be talking about testing hypothesis in comparative analysis. Now, hypothesis is just an assumption, or it's just a prediction that an event will occur. If this event occurs, we now go back after some tests statistically, then we now go back to our assumption and now approve our assumption. For example, if I made an assumption that Group A is not different from Group B, I'll need to run statistical tests to prove that assumption. If I prove the assumption right, it means I proved that group A is not different from group B. Statistically, we will say there is no difference between group A and group B. That is how to say it statistically, by stating that there is no difference between group A and group B. Saying there is no difference, that no, that negation in stating of a hypothesis is called null hypothesis. There is no difference in group A and group B. That is the null hypothesis. Then when we now run our test and it's proven, and it has been proven otherwise, that is where we can now say, okay, that there is difference, and it as if there is difference, and we now reject the null hypothesis, thereby accepting the alternate hypothesis. That is hypothesis. What about probability? We need to talk about probability as far as the comparative data analysis is concerned. And probability is the measure of likelihood that an event will occur. And this probability is quantified as either a number of 0 and 1, where 0 indicates impossibility and 1 indicates certainty. The p-value is the probability of the event occurring by chance if the null hypothesis is true. If the null hypothesis is true, that's if you accept your null hypothesis. If the p-value is, however, less than the choosing benchmark of 0.05 in most cases, or 0.01, the null hypothesis is thereby rejected. The next slides will explain further. Now, if this p-value is small, it indicates the result was unlikely to occur by chance alone. It means something happened. That is the reason why it did not happen by chance. The difference between group A and group B did not happen by chance. There was a factor. There was other factor. It may be, for example, maybe those in Lagos metropolis have different genetic makeup for them to be able to have that kind of glucose level. It is not by chance. It is by genetic variation. That is not chance. So, and that is what research is trying to prove. And if you want to prove that, you have to do that with your data. That is evidence. So the result is known as statistically significant, which means something other than chance happened. However, a typical example is if you have a p-value, a probability value of 0.18, it means the probability of getting null hypothesis is 18%. I repeat, the probability of getting null hypothesis is 18%. And what is our null hypothesis? Null hypothesis states that there is no difference between A and B. Now, for you to be able to get a difference between A and B, if the p-value is 0.18, if the p-value of our earlier data, the difference between A and B, if the p-value is 18% or 0.18, then it means it is 18% for us to say that there is no association. It's 18% assurance that there will be no association, which is larger than the benchmark. And if you have anything like that, larger than the benchmark, then we reject it instantly and choose the other one. We state that we remove the negation. We state that there is what? A difference, or there is an association. So it simply means if you have a large percentage